All right, page 183, number 11. I'm going to rewrite that as 16 minus x squared to the 1/2, because I bet I'll have to take a derivative. I haven't even read the directions yet. Identify the open intervals on which the function is increasing or decreasing. So I need to do critical points, because that gives me possible extrema. And then the table would give me absolute extrema. That's not really what I want today, though. And I'll do the number line thing, first derivative test. That gives me relative extrema, but it also gives me increasing and decreasing intervals. So it feels like the fourth time I've drawn that little picture. But that's the big picture process that we're headed toward. We want increasing and decreasing intervals. So I need to take a derivative and head down that path. So product rule. First one's easy. Second one, 1/2, 16 minus x squared to the negative 1/2 times negative 2x. I guess we could clean that up here before we put things together. So that would be negative x over 16 minus x squared to the 1/2. This is going to be an ugly derivative here. So dy dx equals first times derivative of the second. So negative x squared, the two x's make x squared, over, I'm going to write that as a square root. I generally prefer seeing it as a square root, but I can't take the derivative of a square root, so we end up having to go back and forth with whether we're writing it as a root or an exponent. It doesn't matter, it's just what's your preference for that particular part of the problem. All right, so there's fg prime plus the other way around. 1 times square root of 16 minus x squared. Okay, so if we were just asked for a derivative, we could box that up and be done. We want to know where that's 0 or undefined, though. So I probably would like to get a common denominator so that I can make it one fraction. And then the top is 0 or the bottom is 0. So I'm going to multiply the top and bottom by that denominator so that I get a common denominator. And that just so happens to be square root times square root. So dy dx is negative 2x squared plus 16 over square root of 16 minus x squared. That's a lot of work, and we haven't really even begun the answer to part of this problem. So critical points would be where derivative is 0 or undefined. So y prime equals 0 if negative 2x squared plus 16 equals 0, where the top is 0. So that would be x squared equals 8. So x equals plus or minus square root of 8. Critical points are also where y prime is undefined. That would be where the bottom is 0. So that would be plus or minus 4. It's a long problem for being the third problem in the set, right? Usually you'd think number 11 would be a straightforward, easy situation. Let's see. So negative 4 negative square root of 8, square root of 8, and 4. And I have to test those into my derivative because the goal of this thing was to see where am I increasing, where am I decreasing. So let's try negative 5. Something between negative square root of 8 and negative 4. Negative square root of 8 is not quite to negative 3 yet, so we could use negative 3. And once we figure that out, it's easy on the other side because it's mirrored. Alright, so from here on it is just algebra, really. I'm just plugging in to see what happens. So I plug in negative 5. I squared it before my brain finished saying the word. That'd be 25. Negative 50 plus 16 is negative. Over. Let's see, square root of 16 minus 25. Uh-oh. What's going on there? Square root of a negative number. What's going on there? And actually, it happens all the way back here in the function. If I tried to plug in negative 5 there, I'd be taking the square root of a negative number. So it's not increasing or decreasing. In fact, it doesn't even exist over there. And if we're okay going out of order, I'm suspicious now of the 5 on the other end. Let's see, I would get negative in the top, and again the square root of a negative number. So it's not increasing, decreasing, constant. It just doesn't exist. The derivative doesn't exist, and because the function doesn't exist. So I thought I was going to have 5 intervals. I really only have 3 intervals, unless we end up throwing any more out here. Right, if we square negative 3, you get 9 times negative 2 is negative 18 plus 16, so that's negative. Square root of 16 minus 9. So negative over positive is negative. So that's a decreasing interval. Usually they alternate, but this one's already been weird, so you don't want to just trust that. 16 over square root of 16. Finally an easy one. F prime, we should be clear, F prime is positive. That means F is increasing. And my guess is 3 will be decreasing, especially since the only x terms are squared, so whatever happened to negative 3 will happen to positive 3. But you can plug them in and see negative 18 plus 16 over square root of 16 minus 9. So negative over positive is negative. So F prime is negative, that means F is decreasing. So F is increasing from negative square root of 8 to square root of 8. F is decreasing from negative 4 to negative square root of 8 and square root of 8 to 4. My goodness, that was a 9-minute problem.